Hi, in this video tutorial, I will talk about NDVI. NDVI, as we know, is a normalized difference of vegetation index. It helps us to understand the vegetation. So we'll talk about NDVI. As a definition, we can say that NDVI is a vegetation index to monitor the condition of vegetation or vegetation health. NDVI is the most commonly used vegetation index for monitoring vegetation globally as well as locally also. So, uh, uh, by vegetation, we can understand that it may be a forest, it may be a grassland, it may be a bushland, it may be another form of natural vegetation. And we can also study the agriculture also. We can study the crop health. So it's very important to study the NDVI, and it will help us to monitor the environment and as well as human activities in the form of agriculture. So before we go to the software demonstration, it is very important to understand means the concept of the energy interaction with especially with the vegetation here. So in this graph we can see that this horizontal scale is showing the wavelength and vertical showing the reflectance here. So how vegetation interact with the energy. So energy we can divide into different wavelengths here, and at different wavelengths, the response of the vegetation will be different here. As you can see, this green line, it's showing the healthy vegetation. So you can understand here that the visible part, which starts from 0.4 micrometer, or we can say 400 nanometer to 700 nanometer, this is the visible part. Blue, green, and red. So in all these blue parts here, the reflectance is lower only. It is little higher in green part, but in rest, especially in blue and red, it is lower. And this is the visible part. Why we are calling visible? Because this is visible to us. Beyond 700 nanometer, the graph is very high here. You can say 90% reflectance. So which wavelength is very important to study the vegetation? Either it is very low or it is very high. So the lower part is the red part and the higher part is around 0.75 or 0.8 micrometer. Here this is nanometer, so we can say 700 to 800 micrometer. If we are having the information of this energy, either near infrared energy, this is near infrared part, or red part. So red and near infrared part is very important to understand the vegetation. Okay, so the index is composed of these two parts, red and near infrared. Here in this slide, this NDVI is given in mathematical expression, and this is NIR minus red divided by NIR plus red. If you will see this image here, you can find there are two. One is healthy vegetation and another is stressed vegetation. So what is the difference in between these two form of vegetation? The healthy vegetation is showing that here NIR is 50%, red is 8%. So the most important characteristics of healthy vegetation is it will absorb more red energy and reflect less red energy. This is the most important characteristics here. And another important characteristic is if it is healthy, it will reflect more NIR. On the other hand, if you will see the stressed vegetation, what change will come? NIR will reduce from 50 to 40%, and red will increase many times more. So this is very important, okay? Red reflection will be higher. So if you will put these values in the formula, you will find NDVI, the healthy vegetation is 0.72, and in stressed vegetation, the NDVI is 0.14. So this is a very important, example which will make you clear that what is NDVI and how it works. So for this tutorial, I will use this NOAA, CDR, AVHRR, and DVI data. The temporal character is that this data is available right from 1981 to the present. The provider is NOAA. In the description, you can see that this data, the spatial resolution is 0.05 degree. It is approximately 5 kilometer resolution. So I'm using this data for this demonstration because uh, there are another data also which we can use individual bands to calculate NDVI. But here with the help of this data, we can see direct NDVI. So in another tutorials, we will take another data set. But for this, I'm using this data. So to demonstrate, I will use Google Earth Engine. First, I will configure my map. So I will keep 40-degree longitude, 8-degree latitude, and zoom level 5. The next I have to give my data set. For that, the variable will be data set. It's an image collection, so here I have to give image collection. This ID is NOAA, CDR, AVH, RR, NDVI, and VS. So actually this is a image collection. Out of this image collection, I have to select the date. I have to filter it. Let's say 2019. First Jan to maybe June. Okay, close it. So here I have given this address. Then this variable next will be my NDVI. What NDVI is? My data set, which is I have given up. What I have to select is NDVI. NDVI. So the visualization parameter I have already, I have set already visualization parameter here. Let me explain you this visualization parameter. Minimum I have given minus 1000 because my interest is to show the NDVI. So here, and the scale factor is 0.0001. What does it mean? When you will multiply with this value, then it will give you minus 0.01. So I'm not going to much in the lower part. I'm just touching the boundary area. Okay, so it is not minimum NDVI but close to zero, that is minus 0.01, but minimum may be minus 1. But I am not interested those areas where there is no vegetation. Okay, so I'm giving just to better visualization. And the maximum is 500. What does it mean? It means 0.5. Sorry, 0.05, because above 0.05 very less area will be covered by above this value. If you want, you can increase also, but let's see. The pellets are given here, which you can note. And now the next is I have to add this layer. So first is the name of the layer. The name is NDVI, that is here, NDVI, this one. My second will be the visualization parameter, which is given here. And the next is what name I want, that is NDVI. It's done here. Close it. Thereafter we can run it here. NDVI, that is, oh, I think it should be not, this is not S, this is 5. Sorry. Okay, so we have got an image here, and in this image you can see the pellets. So this 0 is indicating that where there is no vegetation, but as you are moving from this close to red color to the dark green color, the vegetation is increasing here. You can modify these palettes also, and this is the range which I have given, like this. So this is the way you can visualize the NDVI data. If you are interested to download this data, you can give the download code below this map layer. And the important thing is, if you are changing the time, then you can see that how NDVI is changing of a place. Suppose this time is January time to June, but January to June is because this is in most of Ethiopia, in most of Ethiopia, it's not a rainy time, but if I change to 6 to maybe September, then you will find it is more greener, or NDVI will increase, because now this is the time of rain, and during September the NDVI you will find uh, is more in this region. Here you see, especially this Amhara and this western part of Tigray region are receiving more rainfall, and due to this this area is more greener. So you can study, within the year or among the years. For instance, 2015, as you know, it was a time of El Nino effect. So due to this El Nino, which areas were affected more, you can study. And if you know the air, then you can see 2000, suppose here 2015 was the El Nino year. So you observe the change here. This is in 2019. And now I'm giving El Nino year. You can see here that some part of Ethiopia, this NDVI is reduced due to reduced rainfall due to the effect of El Nino 2015. You see, some part here got less they received less rainfall. That is why these are the patches where you can observe the huge impact of this El Nino event in these areas. So there are many more things you can evaluate, you can understand with the help of NDVI data, and how we can calculate NDVI using different bands, using different data, that I will discuss in next tutorial. Thank you very much.